All right, let's talk about something real. We're going to take that machine learning project of yours, the one that feels more like a solo science experiment, and turn it into a professional engineering powerhouse. And the very first step, it's all about mastering your code repository.
So, does this sound familiar? Your project folder is just a mess of files, right? You've got modelfinal.py, modelfinalv2.py, and yeah, my personal favorite, modelreallyfinalthistime.py. Look, we've all done it. It's a classic trap, especially when you're coming from a data science background. But it's time to leave that chaos behind.
So, what's the solution? It's the code repository. I want you to think of it as the official central hub for your entire project. It's that single source of truth that gets your work off your laptop and onto a shared, secure platform. Honestly, this is the foundation for everything else we're going to do in MLOps.
Okay, so what do you get by using a repository? Well, it really comes down to 4 massive pillars. First, version control. This is your time machine. You can literally go back to any previous version of your code. Next up, collaboration. This is how your whole team can work together without stepping on each other's toes. Then there's the single source of truth. No more guessing which version is the right one. Everyone is on the same page. And the last one, the big one, is automation. This is where every single change you make can kick off testing and deployment pipelines automatically. This is the real core of MLOps.
All right, let's get practical. How do you actually set one of these up? Getting these first steps right is so important. Trust me, a little bit of care right now is going to save you from huge headaches later. First up, and this might seem small, but it's not, the name. In a team, this is a huge deal. Having a clear naming convention, something like team, domain, technology. So forecasting, bikes, ML. It just instantly tells everyone what's inside. No more confusion, just clarity from day one. Now, what you put in your repository is important, but what you keep out is just as critical. And for that, you have the .gitignore file. I love this analogy. Think of it as the bouncer for your project's nightclub. It's just a text file with a list of things that Git should totally ignore. It's absolutely essential for keeping your repository clean and, crucially, secure. So what gets kicked out by the bouncer? Rule number 1, secrets and credentials. Never, ever commit API keys. Second, your virtual environments. Those are just for your machine. Third, large data files. Your code repo is for code, not for gigabytes of raw data. And then you have the little stuff, like those annoying system files and compiled code that just create noise. Keeping all this junk out makes your repo lean, fast, and secure. Okay, so you found a repo and you want to get a copy on your computer. You're going to clone it. Now, you can use HTTPS, but the real professional way to do it is with SSH. The setup is simple. You create a key pair, you give your public key to GitHub, and bam, you can now access the repo without ever typing a password again. It's not just more convenient, it's way more secure.
And listen, I really need to pause here for a second because this is non-negotiable. Your private key, that is literally the key to the kingdom. It's like your master password for every single repository you can access. So guard it with your life, never share it, never ever commit it to a repo. Just keep it safe.
All right, so our repository is set up and it's secure. Now, let's get into the day-to-day stuff. How does this actually change how we work? It all boils down to 3 fundamental concepts: commits, branches, and tags. First up, a commit. What is it? It's the smallest unit of work. The best way to think about it is like a save point in a video game. You've just accomplished something meaningful. Maybe you fixed a bug or added a small feature, so you package up those changes and you commit them. It's your project's history, one snapshot at a time. But where do you make these commits? You don't just do it anywhere. You do it on a branch. A branch is like a parallel timeline for your project. It lets you go off and experiment, say, with a totally new model architecture, without any risk of messing up the main stable code base. It's your safe sandbox. And rounding out our trio, we have tags. If a branch is a fluid, moving timeline, a tag is a permanent, stone-etched marker. It's like putting a big, shiny sticker on one specific commit and saying, this one is important. This is how you label your official releases, like v1.0.0, so you can always find that exact version again. And just making commits isn't enough. How you describe them is a huge part of being a pro. Take a look at this. This is an example of what's called conventional commits. You see, it has a type, like feat for a new feature, a quick description, and then more detail below. Following a standard like this makes your project history so much easier for anyone, including your future self, to understand. Okay, so we've got the solo workflow down, but now it's time to level up. How does all this work when you're on a team? This is where we really transition from just being a data scientist working alone to being a true collaborative ML engineer. And for teamwork, you really need to understand the difference between a branch and a fork. It's pretty simple, actually. A branch is for working with your own team, inside your repository. A fork is when someone from the outside, like an open source, makes a complete personal copy of your repository to work on. So, branches for internal work, forks for external contributions. So this leads to a really, really important question. If you have all these people working on all these different branches, what stops someone from accidentally merging broken code into your most important branch, the main branch? The answer? You set up some rules. They're called branch protection rules, and they are literally the guardrails for your main branch. You can enforce things like, hey, nobody can merge anything without a pull request, or you need at least 2 other people to approve this change. And my favorite, all the automated tests have to pass before you can even think about merging. It's all about building a safety net for your code.
And here's where it all comes together. All this work, the clean commit history, the safe branches, the collaborative process, it's all been leading up to this. The ultimate payoff in MLOps, automation. At this point, your repository is no longer just a storage folder. It becomes the living, breathing heart of your project. It's the trigger point. Every single time someone pushes a new commit or opens a pull request, it can kick off a whole chain of events automatically. Running your tests, checking your code quality, maybe even training and deploying a brand new model. And the cool thing is, you have so many ways to do this. You've got tools like GitHub Actions that are built right in, or you can get creative with webhooks to trigger your own custom systems. And there's a whole marketplace of other apps you can plug in to do all sorts of specialized jobs. The possibilities are pretty much endless. So let's wrap this up. Your repository, it is so much more than just a place to dump your code. It's the active foundation for your entire MLOps practice. It's what makes versioning, collaboration, and real quality control possible. So the real question isn't if you should be doing this, it's what are you going to build and automate first?